Assalamualaikum everyone. We are from 563 Audit. My name is Nawan Azri.
My name is Audit Arifah.
My name is Noreen Sasabila.
I am Nur Anissa Eliana.
My name is Alia Nadia.
And my name is Nur Hansa.
Today, we are here to conduct our road safety audit for our project. Stay tuned.
Okay, so this is our selected location for our group project. We have north side, east side, west side.
The goal of the road safety audit project is to assess the safety issues at a selected cross-section in the campus of University Technology Mara Shah Alam. The selected intersection is at intersection near Faculty Science, Computer and Mathematics. To achieve the objective of this project, site inspection has been made at the intersection. There are several aspects that we observe for on-site road safety audit.
Speeding.
As you can see here, your ITM has clearly set a speed limit of 25 km per hour. The vehicle that has passed through this road exceeds the set of speed limits. This will increase the risk of accidents, as speeding will reduce drivers' reaction time and ability to drive safely. This possible accident will increase, especially at intersections where the vehicles and the pedestrian may be crossing paths.
Alignment.
Next is alignment. For this junction have good feature where it have vertical curve with proper sight distance to allow enough stopping sight distance for driver to see another vehicle. Vehicles sometimes exceed safe speeds when going downhill through horizontal curve, where braking lead or insufficiently can lead to loss of control.
Cross section.
Next, I will explain the principle of design for safety, focusing on cross-section elements. A cross-section includes everything you see if the road is cut sideways, like lanes, shoulders, and the road sides. The lane width was just enough for safe vehicle movement, but not too wide to avoid encouraging speeding. While the roadside clearance and recovery, it can be seen that no safe clearance between the edge and the roadside of the road, where the big trees are covered all along the roadside. Lastly, the shoulders and the verges was not have adequate shoulder width to help alert the drivers who drift off the lane.
Geometry layout.
We move on to the next element in road safety audit, that is geometry layout. From our observation, there are no painted islands on the minor road for a guidance for the vehicles to turn left or right. Then, the west approach only has one lane per direction with no dedicated turning lanes. This could cause conflicts, especially when one vehicle is waiting to turn while the others are stuck behind. Then, there are no marked pedestrian crossings or sidewalks, creating potential risks for pedestrians moving around the intersection area.
Traffic signal.
As you can see, there is no stop or give way signage at this intersection, so the driver will not stop at this intersection to cross the junction.
Visual aid.
As we can see from the picture, the stop line and the directional arrows are present but may not be clearly visible from a distance, especially during rain or at night. Then, during the day, the junction has good natural light. Sunlight is enough to help drivers and pedestrians see clearly. This makes it easier and safer for people to use the road. However, lighting appears limited at the junction at night. Poor lighting can reduce visibility at night and increase crash risk.
Vulnerable road user infrastructure.
Next, for vulnerable road users such as pedestrians and the cyclists, the dedicated facilities have shown that the provision of the motorcycle lanes are not physically separated from vehicular lanes. For safe crossings, it proved that there is no use of zebra and pedestrian crossing at appropriate locations. Lastly, the good lighting shows that the poor lighting can reduce the visibility at night for pedestrian and the cyclist path, as the trees might block the lighting a bit.
Roadside safety features.
Roadside safety features, we observe that the paint marking on the road such as lane light and signage are fading or nearly disappearing. This can confuse drivers, especially at night or during bad weather, and it may lead to accidents due to the unclear road guidance. Next, we also observe that some of the road barrier or guardrails are not in the good condition, especially at the sharp corners. The existing barrier provide a low protection, increasing the risk of the serious accident if the vehicle lose control in this high-risk area.
Street lighting.
As you can see, during our morning site audit, we observed that street lamps are installed along the road. This shows that lighting infrastructure is available in this area. But during the night, we noticed that the lighting was not sufficient. The area felt unsafe and visibility was low in the several sections. This condition increased the risk of accident and may also lead to the potential criminal activities.
Landscaping.
Another assessment, while site inspection, is this junction have overhanging trees can cause problem to pedestrian where the branch may fall on them, and vegetation blocking street light where it can reduce nighttime visibility of pedestrian, cyclist or driver.
Road surface.
Based on our observation, the road surface at the selected intersection was in a good condition. There were no potholes, cracks, or uneven areas, and water drainage works well without any sign of ponding. The road markings were clear and effective, in compliance with British standards for reflectivity and visibility.
Suitable experiments and approach.
Method that we use to justify the road safety at this site are spot speed and junction capacity study at peak hours to define the worst case scenario.
Junction capacity study.
Junction capacity study help in evaluate traffic flow by determine level of service and to justify safety improvement. In addition, it helps to determine whether pedestrian crossing phase are needed. Also, ensure that the intersection can handle current and future traffic volume while maintaining safe and equitable access for all road users. Junction capacity study is necessary in road safety audit, especially when evaluating intersection where safety concerns such as congestion or delays are present. In addition, long vehicle queue can make jaywalking more common, especially if pedestrians feel unsafe or rush during signal cycle.
Spot speed study.
Another suitable experiment and approaches to justify the problem is spot speed study. The spot speed study helps us understand the driver behavior and check if speeding is a safety concern at an intersection. Speeding is a critical safety issue even when it is not obvious. This study gives us quantitative evidence to support improvement like better signage or enforcement. It is also practical because this method is quick and safe to carry out during field visit without affecting the traffic flow. Most importantly, it shows us the actual speed that drivers travel under normal conditions. This helps assess the risk to pedestrians and cyclists, especially when vehicles are going too fast at an intersection. The data collected give objective, measurable evidence, which help in making better decisions for safety improvement. Lastly, it plays a key role in protecting vulnerable road users like pedestrians, cyclists, and motorcyclists by highlighting the risky areas where vehicles are moving too fast.
Analysis, interpretation and mitigation proposals.
In this video, we will highlight a real speeding problem observed in several high-traffic areas around UITM. To understand the severity of the issue, our team conducted a spot speed study using radar gun to collect vehicle speed data. To reduce speeding within campus areas, we recommend 3 impactful mitigation strategies as shown. From the data collected, we observed that a majority of vehicles travel above 30 km per hour, with some reaching speed close to 40 km per hour, far above the campus regulation. This clearly indicates that speeding is a real safety concern at UITM.
From junction capacity analysis, we found that this is a two-way stop control intersection, where the minor road is from Jalan Cendekiawan 1/15, while the major road is from east and west of Jalan Ilmu 1/1. We observed that there are moderate vehicle flow during peak hours and frequent stopping on the minor approach. Our team has collected data and analysed it using Sidra intersection software to evaluate performance and safety rates of the route. From junction capacity analysis, we found that this is a two-way stop control intersection, where the minor road is from Jalan Cendekiawan. According to the Sidra movement summary, the south approach has an average delay of 11.8 seconds per vehicle that is rated level of service B. Then, the west approach shows the longest queue with up to 2.9 vehicles at peak hour and a delay of 5.7 seconds rated as level of service A. Lastly, the east approach operates a near free flow condition. According to the Sidra movement summary, the south approach has an average delay of 11.8 seconds. Although the intersection performs well overall, we identified two potential safety issues. The first one is the south approach has the very high stop rate of 0.98, meaning vehicles have to come to a complete stop before they can join the main road. If not completely stopped, it can lead to a side impact crashes. The second one is the westbound approach queue is close to 3 vehicles long, which may cause unexpected delays or rear end conflicts. These issues could increase the risk of crashes, especially if traffic grows in the future. In conclusion, the intersection is currently operating efficiently, but there is a room for improvement in visibility and queue management.